This is chapter 3, lesson 5. We're going to talk about arithmetic sequences, which is having a string of numbers that have a common difference. So we've got the numbers 2, 5, 8, 11. And with these numbers, each step increases by 3. Because there's a common difference, a difference of 3, we call this an arithmetic sequence. Now each of these individual numbers we call a term. The first term is 2, the second term is 5, the third term is 8. And we denote that, we write that with an A. So right now, A sub 1, that means my first term is 2. And A sub 2 means my second term is 5. If I had A sub 30, that'd be my 30th term. The 30th term is something, I don't know what. But each of these A sub stands for a different term. So again, like A sub 3, the third term is 8. These are going down 10 each time. Since they go down 10 each time, it's an arithmetic sequence. The common difference is D. These are going up by 0.7 each time. So here the common difference is 0.7, and that's an arithmetic sequence. So the common difference, we do use letter D. D stands for the common difference. Common difference sounds like an oxymoron. How can things be common and different? But you're finding what's different and what's all the differences. What do those all happen on? If you don't have a common difference, this is up 1, up 2, up 1. This is not an arithmetic sequence. And here this is up 1, down 1, up 1. Just because there's a pattern, there still is a pattern, and you could, find other terms of sequence if you wanted to, but it's not called an arithmetic sequence because there's no common pattern. Okay, let's take this one and look at it more closely. So it's 2, 5, 8, 11. Obviously the next term will be 14, and after that comes 17. But what's a little bit more useful than finding each next term is being able to skip forward to find some other term. Like say you want to find the 300th term or the 10,000th term. I mean, right now I know that the 6th term is 17, and from that I can find the 7th term would be 20, because we're increasing by 3 each time. But if I wanted to find the 300th term, I don't want to count from the 7th term to the 8th term to the 9th term all the way ahead. I want to find a jump or a shortcut or a way to skip ahead. So we think about how far we have to go. From the number 2 to get to the 300th term, so really I'll say it this way. From our first term to get to our 300th term, we have to increase 299 times. We have to take 299 steps. Well, each of those steps is going to be plus 3, plus 3, plus 3, plus 3. So we're really going to be adding 3 299 times. Well, the quick way to add 3 299 times is to multiply. So I took 3 times 299, well that's just under 900, that's 897. I really increased by 897, but I did that starting from 2. So from 2, I went up 3 times 299, and that's going to give me my 300th term. So the 300th term of the sequence is 2 plus 897, which is actually 899. We're going to do another example. Here, we'll skip this. Here we're going to find the nth term and make a formula to find that nth term. Well, when it says write a formula to find the nth term, that means have something that we can plug numbers into to generate any term. Like say I wanted to find the 51st term. I want to have some formula that I can just plug a few numbers into or plug something into to get that 51st term. Just think about what's going to happen here. To get, for example, the 51st term, I'm going to have to take 50 steps. Because I'm already at that I'm already at the first term. I'm starting at the first term. I'm going to take 50 steps, and each of those steps has a distance of 6. And I'm going to take that, and I know I'm starting from 4, so it's 4 plus 50 times 6. That's how I find the 51st term. I'd like to find the 93rd term. I would start at 4, and I would take 92 steps, and each step is size 6. And to find the 103rd term, well, 103, I'll just use a different number on the end. To find the 108th term, I'll start at 4, and I'll add 107 steps. So these are all specific examples. This isn't a formula that gives me any term. This is me finding one term at a time. But what I want is a formula to find any term, to find the nth term, where n stands for any number. That's the idea of finding any term. Well, I'll just take what we're doing here. I'll take this process and do it more generally. So really what we're doing is if I want to find the nth term, where n stands for any number, if I want to find the nth term, I'm starting at the first term. I'm increasing by n minus 1, because here it's like n is 51, so this is n minus 1. Here it's like n is 93, so n minus 1 is 92. Here it's like n is 108, so n minus 1 is 107. I'm going to have the n minus 1th term, and then each step at a length of 6, and that's what we call our common difference. So in this case, my formula would be to find any term. I'm going to start at 4. My first term is 4. And each step has a length of 6. That's a formula to find any term. So now suppose, I keep doing these examples, but that's because that's the point of the formula. The point of the formula is now we can find anything. Suppose I want to find the 33rd term. If I plug a 33 in for n, I plug a 33 in for n here, so I'm also going to plug a 33 in for n here. And I calculate. (32 times 6 is 192. The 33rd term is 196. So to kind of make this a bit more formal, to find the formula for any arithmetic sequence, this over here, looks like this. You have a sub n, which is the term you want to find. N stands for the actual term that you want. So like if I plug a 12 in for n, I'd be finding the 12th term. A sub 1 is my first term. D stands for common difference. On the last screen, I wrote it like this. And that means the same thing. So for example, here, my common difference is 4. It's negative 4, going down 4 each time. My first term is 11. So the formula would be a sub n equals 11 plus, I'll go here, my d value is negative 4 plus negative 4 times n minus 1. Here's a formula to find any term. If I wanted to find the third term, I plug a 3 in for n. If I wanted to find the 33rd term, I plug a 33 in for n. Thank you.